It's summer, and you know what that means. Manipulating the spin and speed of a flying sphere to change its velocity and elude a Homo sapien swinging a third-class lever, also known as baseball season. Hello fans of sport and physics alike, Julian here for D-News. Baseball is often called America's pastime, and it's mostly known for being a relaxed-paced game that goes great with beer and hot dogs. But you know what else goes great with baseball? Science, that's right. Of course, any physical activity is going to have some physics behind it, and one of the more nuanced aspects of baseball to a non-fan is the physics of different pitches. Justin Allegri, broadcaster for the San Jose Giants, explains there's a lot more to a pitch than just rocketing the ball over the plate. By changing the grip, pressure, and release of the ball, the pitcher can alter its flight path and make the batter's life miserable. The most well-known pitch is the fastball, but there are different variations on the theme. The most direct one is a four-seam fastball, where the fingers are placed across four seams. On release, the pitcher imparts backspin on the ball. The result is the ball doesn't drop as much as it would otherwise, appearing to fight gravity and travel in more of a straight line. The pitcher is taking advantage of the Magnus effect, which is when a spinning sphere affects the air pressure around it, much like an airplane wing. The side of the ball spinning with the direction of travel is essentially moving against the air faster, creating more drag, creating more pressure, and causing the air to push on it. On the opposite side of the ball, air pressure is reduced and the ball travels more easily in that direction. You see it in other ball sports too, like in soccer, or yes, football. I know, rest of the world, you don't have to keep reminding us. Curveballs take advantage of the Magnus effect more, but instead of stabilizing the flight into a straight line, the topspin causes it to drop and cut. Different grips and releases open up more possibilities, like sinkers, sliders, and changeups, but they're all essentially doing the same thing, causing the seams to push air around and change the pressure on the ball. The exception to the rule is the knuckleball. A knuckleball is designed to spin only once in its flight. Moving through the air this way causes a Kármán vortex streak, which is a string of vortices trailing alternating sides of the ball. The effect is the ball wobbles from side to side and its flight becomes impossible to predict. Clearly, the seams play a huge role in affecting the flight of the ball. The seams on balls the pros use are smoother than those used by college players to give them less of an advantage in grip. The lower seams also give the batter an advantage. Because of the reduced drag, a batter will hit the smoother ball farther. You'll also notice balls that get hit in the dirt and scuffed are tossed out by the umpires, because a skilled pitcher can use the scuff to their advantage. Baseball pitches are a great example of people innovating and getting creative to elevate their game. Speaking of insane augmentations, Toyota has been doing some tinkering of their own with the TRD line of Toyota trucks, enhanced to rule the off-road. Of course, the human element is always an unpredictable factor in sports, and sometimes it can ruin the game. Annie discusses the science of blown calls here.
Strike zone are wrong about 14% of the time, according to a recent study that looked at 700,000 pitches. But even worse, they were more wrong towards the end of the game.
Are there any other games or sports with interesting forces at work you want us to cover? Let us know in the comments and subscribe for more D-News. I'll see you next time.